You might be familiar with monolithic applications and microservices. In monolithic applications, you build your application as a single deployable unit. Whereas in microservice architecture, you will build a set of independently deployable services, each providing a specific business capability. Both monoliths and microservices has their pros and cons. While microservices provide team autonomy and ability to independently scale different services, it brings all the challenges of distributed systems. But with monolithic applications, there is a chance that it can become a big ball of mud over the time if enough care is not taken. In the last decade, microservices became preferred architectural style. But for some companies it worked great, but for some other companies it became too much complexity to handle. Now people are looking for a middle ground called modular monoliths. Modular monoliths are nothing but a monolithic application, but each module boundary is properly implemented so that it doesn't become a big ball of mud. In this video, let us see how Spring Modulith project helps us to build a modular monolith with a sample application. So here is our sample repository, which contains a module called monolith. This is nothing but a simple springboot application, which is a bookstore application containing catalog, orders, inventory modules. And there are a couple of other packages like common, which contains some common code that can be usable by other modules. And there is a config package containing springboot application configuration classes. So currently it is developed as a simple monolithic application, and we are going to see how we can use Spring Modulith to make it as a modular monolithic application. So before that, let us understand how the current code is organized and what kind of a features it is implemented. Let's take a look at how the code is organized inside each of the modules. So here in our catalog module, we have two sub packages called domain and web. Inside the domain, we have the core domain models like we have product-jpa entity, and we have product repository, which is nothing but a spring-data-jpa repository, and we have product service, which calls product repository. And here we have product not found exception and a product record. So from our product service, we use product repository to fetch the data from database, and also we are not returning the data using product entities itself, because we don't want to expose our internal database structure as a response. So we are converting the data into product record and then returning the data. And here in our web package, we have product controller, which is talking to product service and fetch the required data. We have only two API endpoints. One is to fetch the products with the pagination support, and another one is to get the product information for the given code. There are two API endpoints. And if you take a deeper look, we can see inside our domain package, we have product service, which is a public class. So anybody can call this product service and any of its methods. But if you take a look at the product entity, this is not a public class. This is only used inside this domain package. And also our product repository is also not a public one, and it is not accessible outside of this domain package, because we don't want to give access directly to the repository. Anybody who want to use any of the catalog package, they should call through product service only. And here we have product not found exception that can be public, and also the product record that should be public, because we are returning the data from product service through product entity instances, product instances. And also our product controller is also not a public one, because ideally this class should be used by the framework itself, and even these methods are not public because these are called from the Spring Boot framework itself. These are not supposed to be called by any other code. So I would say this is already pretty decently created and organized inside the package. And also the other modules like orders and inventory is kind of very similar. We have both domain package and web package. And in orders package, we can even see there are more sub packages like we have models. So While implementing various other services like order service, we have various methods like to create an order or to fetch an order for a given order number. So there are more endpoints. Like if you take a look at order controller, we have a API endpoint to create a new order where we get request which we are modeling with create order request, which is nothing but a record. And similarly, inside this we have order item and customer. So we are going to get the data in this structure, and we are returning the response with create order response, which contains just order number. And similarly, we have different models, and instead of putting them all of them inside the domain directly, I have put them inside this models package. And also I have an events package which has order created event. So when we create an order, if we go to order controller and if we take a look at order service.create order, once we store the order details, we are creating an instance of order created event, and then we are publishing that event, okay, through application event publisher, which is provided by Spring framework itself. And also here, when we get a request to create order, we are validating it. In this, we are using product service from the catalog module to fetch the product information for the given product code, and then we are comparing whether first this product exists or not, and if the price is matching with the catalog product information or not, and if any of these are not matching, it is throwing the invalid order exception. So that way our orders module depends on the catalog module. And also, as I mentioned, we are publishing an event on successful creation of the order. We are publishing order created event, and this event is consumed by our inventory service. So here we have inventory service, and which is listening for that order created event. Ideally, we should update the inventory in the database, but right now simply I am just logging update the inventory for so and so product code. So that way, it is not directly depends on the orders module, but it is going to consume the events produced by the orders module. So currently this is our implementation. I would say, as I mentioned already, we have hidden some of the JPA entities or repositories using package protected scope, and I would say this is decently organized. If you take a look at some of the other packages like common, inside this we have models which contains a paged result, which is nothing but to contain the data when we request for a paged information. Like if you are returning a set of products with pagination, I am including the current page data along with other information related to the pagination. And this can be used by any module. This has nothing specific to catalog or orders or any other thing. So that's why I put this into common models package. And also we have config package, which is having a global exception handler by using REST controller advice. So from any of the modules like orders or catalog or inventory, if they throw any exceptions and they are not handled, so finally they are going to be handled using this controller advice. So if a catalog module throws product not found exception, it is going to handle here. And also order modules might throw order not found or invalid order exception, they are going to be handled here. So we have global exception handler inside this config package. So this is our current module and current module structure, and we have this monolithic application with us. As I mentioned, to me it is already in a decent shape, but let us see when we apply Spring Modulith, what kind of problems it see in our implementation and how we can make it modular monolith by using Spring Modulith. Okay. In our current repository, I have created another module called Modulith, and I have copied the existing implementation from the monolith module. In addition to that, I have added Spring Modulith dependencies here. So if you want to add Spring Modulith support, you can go to start.spring.io, and in addition to the other starters that you usually add, you can add this Spring Modulith starter as well. And here if you try to see what it is going to add, the current version is Spring Modulith version is 1.2.0, and it is going to add this Spring Modulith starter core, and also it is going to add Spring Modulith starter test modules, and also there is a bill of material dependency added here. So I have added this support, and in addition to that I have added a couple of other dependencies as well. In addition to Spring Modulith starter core, I have added Spring Modulith Actuator and also Spring Modulith docs. We will see how we are going to use these module support as well. In addition to that, we have Spring Modulith starter test as well. So with this one, I have created one simple test that checks whether our current code is implemented according to the Spring Modulith expectations or not. So here we have this modularity tests, which in which we have created this application modules, which is nothing but application modules of, this is the root our starter class. Basically this is our main entry point class, which contains this springboot application. Okay, so here we are passing this class and then try to create modules, and then here we are calling modules.verify in our test, and let us run and see whether our current code is in accordance with Spring Modulith or not. So as you can see, the test failed, and it seems there are a bunch of violations with the current code implementation and code organization. So in addition to reporting this, we can also generate the documentation, but first we are going to fix these issues, and then we'll see how we can generate the documentation as well. So in order to understand and fix these issues, first let us understand the concept of Spring Modulith. In our application, currently we have our main entry point class application inside bookstore package. So the bookstore package is considered as the root package, and according to Spring Modulith, all the direct sub packages of that root package are considered as application modules. So that means catalog is a application module, common is a application module. Similarly, config, inventory and orders, they are all application modules. So in each application module, if there are any classes directly inside this application module package like orders, if there are any public classes, that is considered as the API for that particular module. Any classes that resides any of its sub packages are considered as internal to that particular module. That means no other module can directly access the internals of other modules. So here in our case we have orders, and inside from our domain package we have order service, which is trying to call product service, which is there inside domain packages of catalog. But as we just mentioned, catalog, this product service is not there inside direct catalog package itself, but it is there inside this domain package. That means this is considered as a internal to this catalog service, which is automatically not exposed to other modules. That's why we cannot directly access product service from order service. So now any classes within a module can talk to each other, like we have our order controller that can talk to any of the classes that are there inside this domain package, because they are all internal to this orders package itself. So if one package, one application module want to talk to other module, it can only talk to the public API. And public API in the sense any classes directly are there in this root package of each module. So now with this knowledge, let us take a look at the test failure and try to understand what are these violations. So here the first violation we can see, our module catalog depends on non-exposed type paged results within module common. So here we have our common, but the paged result is not directly inside this common package. It is there in a nested package called models. That's why this paged result is considered as an internal component to this common module. So that is why when we access this from our product controller or even product service, it is saying you cannot access that. That is a private internal part of commons package. So how we can solve this? Either we can directly move this into this root package. So let us try and move this to common root. Okay, so now it is there directly inside this common package. Now let us run this test and see whether we still get that or not. So now we can see that violation is gone. Now it is not reporting that violation because now it is a public API in this common module which is accessible by other modules. But here the reason I want to put this inside this modules package is there can be more things in the common package. Maybe I want to have models, and I also want to have some common exceptions, and also I want to have utils. So I don't want to put all of them in the direct common package. I want to put in various sub packages. So how do I make them accessible to other modules? So let us take a look at the documentation and see how we can do that. So one approach is you can name, we can give it as a explicit named interface. So here if we take a look at, so there is a feature called named interfaces. That means you can create a package info.java file and then you can give a name, explicit name to it. So like this, if you give a name to this, it will automatically be available for other modules as well. So let us try to have this package info class. So here inside the models, I am going to create a package info Java file and I am going to give a explicit name to it. So here I am giving common modules, common models. Okay, so what this named interfaces do, the effect of that declaration is twofold. First, code in other application modules is allowed to refer to some SPI interface, that is nothing but this particular sub package code. Okay, and the second one is the application module are also able to refer to the named interface in explicit dependency declarations. So we'll see what that means. So here I gave a explicit name to this particular package, sub package models. So with this, if I run this again, modularity test, now you can see the same violation is not shown here, like a common is being accessed from catalog. That violation is gone because I explicitly gave this name and it is allowed to be accessible by other modules as well now. So that is one way to solve this issue. Another one is, let's say, as I mentioned, if I want to have more sub packages, like I want to have exceptions or utils or something like that, I don't want to give for each package, I don't want to create package info and then give name to it, because they are kind of very common utilities, and instead I just want to make all the code that is there inside this common module available to all other modules. I don't want to give each package a specific name and give permission to use by other modules. So how I can do that? There is other concept called open modules. Let's say open modules. So basically, if you create a package info Java class and you can specifically specify this application module is of type open. So that means all the code in this package, in this module is accessible. You don't need to specify at each sub package level, but at the root level itself. And what that will do, it marks all the classes in all the sub packages also are accessible for other modules. So here I'm going to make this as open type module. But here one thing to remember is it is intended primarily to use with the existing legacy application, so that you can gradually migrate your existing code base to Spring Modulith structure. But even then, in this scenario, I feel this is fine to make this as open module, because it's all just utilities and common models, and I don't want to create a package info for each of the sub packages. I just want to make it available for all other modules. So that's why I just created this package info and make this as a open type module. So now again, if I run this, it will not show that specific violation regarding accessing this page result. So now you can see that violation is not there. Now let us look at the next set of violations. Here, module orders depends on non-exposed type product service within module catalog. And also it is giving the similar violation, orders depends on non-exposed type product within the module catalog. So apparently from our order service we are accessing product service and also product, which is there inside the catalog domain package. So as I already mentioned, this is an internal part of the catalog module. So how do we solve this? So one way to solve this is moving this product and product service, which is nothing but the public API, to its root package of catalog. So here if I move that, what happens? Earlier both product service and product repository are within this domain package, that's why we are able to access that. But now that we moved the product service into domain package, this catalog package, we are not able to access that anymore. So here we need to make this as public interface. So now it is going to work just fine, and here in the repository as well, it is public and we are accessing this product which is there in this catalog package itself. Now if you run this test, we should see that violation should not be there anymore. So now we can see that violation is gone. However, earlier the reason why we make it non-public is so that nobody should directly be able to access product repository and everyone should access only through product service itself. But now that we make it as public one, we can anybody else can directly use it, right? So let us try to use product repository directly from, let's say, order service. So let me inject that into this order service private final product repository. Because this is a public one, I can inject this. But if I try to run the same test, let's see what happens. So here it is saying module orders depends on non-exposed type product repository. So though it is a public one and technically as per the Java access modifiers we are capable of using this, Spring Modulith is saying we should not access this. This is a private internal part of the catalog. So that is how we are protecting our catalog domain. So this is how we can solve, and this is one way. I would say another way is, still I would like to keep product service as product service IMPL within the domain package itself, and I would make this as an interface So I will make this as an interface like this. And I will make this product service IMPL implements that. Okay. So what is happening now? I am just making this as an interface and define what are all the methods that I am want to expose from my catalog API, and I am putting this implementation within the internal package itself. So this is another way to solve this issue. And again, I have this product in the root package. That is also fine. Otherwise, if we want to put it in a sub package, we can use that and then give a named interface to that sub package. But I would go with putting this in the root package of catalog itself. So now if I run this test, it should work fine. So here we don't see orders calling product service violation anymore. So that problem is solved. Now let us look at the next set of violations. So here module inventory depends on non-expose type, orders, domain, events, order created event within the module orders. So here we have this order created event within the orders, domain, event sub package, and we are accessing that from our inventory service. So obviously this is, even though it is a public one, it is not exposed. It is there within the sub package and is by default it is considered as internal to this orders module. So we can use the same named interface technique to make it available for the other modules. So here I would say I will create package info Java, and then I'm going to use named interfaces technique, like let us go ahead and see. I'm going to give a name order events. So now that I gave this named interface to this package, now it is available for other modules as well. Now if I run the test, you can see that violation should be gone. So now that is gone. Now the next one is module config depends on non-exposed type, order not found within the module orders. And also you can see similar one for other invalid order exception, order not found exception. So what is happening, from config package we have this global exception handler, and here we are using product not found, order not found, invalid order exception. So these are residing in other modules, like product not found is there inside this catalog domain package. As I already mentioned, it is considered as a internal to this catalog service, catalog module. So how we can resolve this? Obviously one approach is we can move this into the root package, or also similarly we can move this invalid order exception, order not found exception into the root package of orders, because we are accessing them from our config global exception handler. But now that way we can solve this, but again rethinking, why should we have a catalog related exception handler in a common package? Why not put it in the right place? Like we should move config package, we should have catalog related one into catalog one. Within this config I would rename this to catalog exception handler, and I'm going to handle catalog related exceptions only in that place. Okay, so similarly here in this global exception handler I'm not going to handle product not found exception, and I'm going to move this into orders. Okay, so here again I'm going to refactor orders. So I moved the order related things into its own module. So this is where we need to think. It's not just about exposing all the components to other modules or like that. It is supposed to make you think, are we putting the things in the right place or not. Here earlier we put this global exception handler in a root package of our application, and we are mixing all the different exception handling logic in one place. Ideally, let's say you want to move order module into its own microservice, then you should be able to just take this package and move it into a separate service, because order related, everything order related is there within this sub package. Earlier we have this in a common package. So now that we have put it in the right place, we should be good enough. Now it should not complain, because we don't have anything that is there in the common package, config package, that is accessing private parts of the other modules. So let me rerun this and see. Now everything is green. So this is an exercise where it makes us think, are we putting the things in its right place? Are we mixing the things in different packages and then polluting it? So here I would say this improved a little bit how we want to organize our code base and how we want to expose our components to other dependent modules, things like that. Spring Modulith also helps us to avoid cyclic dependencies across the modules. So right now inventory module depends on the orders module. Now what happens if we try to depend on the inventory module? So now let's see, this inventory service is not a public one. Let us make this as a public one and try to inject this into order service. So here I am going to inject this into orders service, and now if I run the test, we can see Spring Modulith detects this cyclic dependency. So here cycle detected, inventory to order, orders to inventory. So this way it can help us to avoid these cyclic dependencies across the different modules also. So now let me remove this and make this as non-public also. So this is how we can keep still, even though they are all in the same application, we can protect our modules from not having a cycle or not accessing other modules internal components and all. We can also create more strict rules like which module should depend on which other modules or named modules, like that. So right now we don't have any such explicit dependencies defined for the orders module, but what we can do, so let's say here I can create package info.java file and I can define it as application module, and then I can specify allowed dependencies equals to, so here I can explicitly define it can only depend on catalog module. Maybe if it is there, we can specify payment module, like that, so that even though if there are, let's say there is a shipping module, and by default it is allowed to access shipping modules public API, but by specifying explicitly allowed dependencies catalog and payment, our orders module is going to only be able to talk to catalog API and payment API only, but not shipping API. But if we don't specify like this, it is allowed to talk to any public API of other modules as long as there is no cycle detected. So that is how we can make it even more stricter by explicitly specifying which other modules our service is depending on. Now let's say we specified it is only depending on catalog service, and if we run our modularity test, so earlier we have used this, and now it is going to say this is fine. We are accessing only catalog module from orders module. So this is how you can explicitly define. Let's say you want to define some named interface which is there inside nested package structure. For example, right now we don't have such one. Let's say we have, there is a, let's say events, so like that, and inside that we have let's copy it from another one, package info, and paste it here. So here under catalog we have events package. Let's name it as catalog events. Okay, so assume there is some events package and some catalog related events components are there inside this package. Now how we can specify, when we by default specified orders module package info, when we say catalog only, it is only allowed to access the high level root components, root API of catalog. We cannot use this one. So how we can explicitly specify that? We can say catalog : and catalog events. So if you want to explicitly define, you can specify like this: the parent module name : and specific named interface, like this. Okay, so this is how you can explicitly define what are the allowed dependencies. So right now we don't need this, and I'm going to remove this and also this. So everything is fine. I have also added this Spring Modulith actuator. So let us see what features it provides. So now I'm going to start the application, Modulith application here. And here I can see the application started. And if I go to localhost 8080 actuator, I can see there is a actuator endpoint for Modulith, and here if I click on it, I can see what are all the modules are there and what depends on which other module. So here there is a common module, it doesn't depend on any other module, and there is a catalog module which depends on common, and also there is orders module which uses component of catalog. So here from orders module we are using catalog module, that is depicting this here. And also there is inventory module, and it also depends on orders, but the type is event listener. So here it is not directly calling any API of orders module. Instead it is using as an event listener of the events published by orders. So here you can see what type of a dependency it has on orders module. So this is a nice view of your application that depicts what are all the modules available in your application and which module depends on which other module and what type of a dependency it is. So this is a nice representation of the module structure you have for your entire application. Now let us see how Spring Modulith helps us in testing individual modules. So here currently we have some tests. In our catalog module we have product controller tests. So right now we are using @springboot test annotation for writing our integration test. But it is going to load the entire application context with all the bins. But for testing our catalog service API endpoints, we don't need to load either inventory or orders module. So what we can do, instead of using @springboot test annotation, we can use @application module test annotation, and we can test this. So what happens is, it is going to load only the current module and invoke these API endpoints and test the APIs. So here if you take a look at the logs, we can see only the catalog related modules are loaded. So here catalog module and all the components, Spring components defined in this module are loaded. Not other modules like orders or catalog is loaded. Obviously this is going to speed up the tests as well. But now let us try to do the same thing for our order controller tests as well. So here again we are using @springboot test. So instead let us use application module test. But this is going to fail. The reason being, it is going to load only orders module, but our orders module is depending on the catalog module by talking to the product service. So here if you take a look at the errors, you can see consider defining bean of type product service. Because it did not load the entire application components, it is not able to identify product service being registered, and it is saying this is the error. So how can we solve this? So here when we use this application module test annotation, here it has some properties, annotation attributes. So by default the mode is standalone. Okay, so standalone means whatever the current module, it only loads those specific components only. So what are the other modules, other modes? So here there is a direct dependencies and all dependencies. So if we use direct dependencies, in our case while testing orders module, it is depending on the catalog module. So here when we use direct dependencies, it is going to load orders as well as catalog module components also. So if we specify all dependencies, it is going to load all the dependencies. So here let us change that mode to mode equals to all dependencies, direct dependencies. Okay, so now let us test this, and it should work just fine now. And you can also see in the log that it is loading not only order component but also, so here you can see it loaded orders and also included dependencies, nothing but catalog components. Though it sounds easy and simple by simply specifying direct dependencies to be loaded, But here we are again from the testing point of view, we are coupling the testing of both catalog and orders. So instead what we can do, we can test orders module in isolation by mocking the dependent components. So here we are going to use mock bean and use this product service. So instead of loading the actual component from other module, we are mocking that bean. So by mocking this, we can define what are the behavior we want, and then we can test our components. So here I'm going to define the mock behavior in this before each lifecycle callback, and here it is bdd mockito. Okay, and that is optional. So as I am using this P100 product code and other details while placing the order and while loading some order details, so I am mocking that behavior here, and now I can run the tests. So here I am going to load only orders module, and I am mocking the dependencies of catalog service. So now you can see in the console, now it is going to load only orders module, not catalog. So here it only loaded order related components. So this way you can test each module independent of other modules, so that you have complete isolation of the modules also. Finally, let us see how we can generate the documentation for our modules using Spring Modulith. So here we can add this Spring Modulith docs dependency here, and in our modularity test, let us add another test that is going to generate the documentation for us. So here we are using documenter and pass the modules reference and write documentation. So now if we run this test, it is going to automatically generate the documentation based on our modules arrangement. So now if we expand this target, here you can see Spring Modulith docs, and inside this you can see for each module it generates a C4 model based diagram here, and here you can see module inventory and module orders. So there is documentation based on the ASCII doctor also. It depicts for each package what are all the Spring components are there, and also there is one components.puml which is generating all the modules and their interaction with each other. So this way, without manually generating this documentation, we can use this automated way to generate the documentation also. As you can see, Spring Modulith is helping us to build modular monolithic applications and yet avoid it to become a big ball of mud. And also it helps us to test each modules independent of other modules, so that in future if we see the need to make any of the module as a separate microservice, it is relatively very easy to extract that specific module and make it as a separate microservice. So I would highly recommend you to take a look at this Spring Modulith and then try it out.